Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Thoriq Alfarizi and my student number is 220605525. And in this video, I will explain and try to solve a example problem of circular economy. So, um, we have a problem which is implementing a circular economy model for electronic waste management or e-waste management. And the problem is given develop a model to manage electronic waste or e-waste using circular economy principles. And so, what is economy principles? What is circular economic principles is its the goal is to minimize waste and maximize resource through reuse and recycling, refurbishing and remanufacturing. So we need to assess the effectiveness of different strategies and propose an optimal solution. So we have our solution here, and we first need to use of course, again, the E5 method. So the first one is intention. So the goal is to minimize electronic waste and maximize resource reuse. And we have the criteria, which is reduction in total e-waste generated, increase in percentage of recycled, refurbished, and remanufactured electronics, cost effectiveness, and environmental impact. And of course, for the sake of God. And the second step is initial thinking. We have the problem, which is to understand the current e-waste generation rates and recycling process, identifying key stakeholders involved, and to determine the life cycle of electronic products where waste is generated. And the method selection is to evaluate different circular economy strategies that includes recycling, refurbishing, and remanufacturing, and to use system dynamics to simulate the flow of materials through this process. And we will have our software or code to do that. And finally, to choose metrics for evaluating effectiveness. So we have three metrics, which is waste reduction, cost savings, and the environmental impacts. Okay. And the third step is idealization. So we have our assumption, which is to assume a constant rate of electronic product consumption. And we have to also assume a certain percentage of consumers willing to participate in recycling programs and to assume fixed cost and effectiveness. Uh, I mean by no, not effectiveness, but it's efficiencies for recycling, refurbishing, and manufacturing processes. And here we have our modeling. Our model is to develop a system dynamics model to simulate the e-waste management process and to create feedback loops to represent the simple flow of materials and to include variables for collection rates, processing efficiencies, and market demand for refurbished products. And we also have our approximation and error tolerance, and it is to set acceptable levels of approximation for collection and processing rates, and to define error tolerance for cost estimates and environmental impact assessments. And finally, we have our instructions. So we have four part in this instruction, which is algorithm development, implementation, execution, and verification. Okay, so the first one is algorithm development, and written here is define. We need to define system components, and that is to identify and model components such as collection points, recycling facilities, refurbishing centers, and manufacturing units. The second one is to establish flow relationships, and that is to create equations to represent the flow of materials between those components. And the third one is incorporate feedback loops, and that is to add feedback mechanisms to represent how improved recycling rates affect raw material demand. And the fourth one, and it's simulate scenarios, which is to run simulations for different strategies to evaluate their impact on waste reduction, cost, and environmental outcomes. And we have our implementation, which is to implement the model using system dynamics software like Vensim or Stella, or in this case, a code in Python, and to input initial data on e-waste generation rates, processing efficiencies, and cost. And finally, the execution and verification. So the execution is we ran the model for a predefined period, for example, 10 years, and we verified the results using historical data on e-waste management that has already existed. And finally, we adjust model parameters based on verification results to ensure a more accurate answers. So, excuse me. This is the example model implementation. And the first one is we need to define system components. We have our collection points, recycling facilities, refurbishing centers, remanufacturing units. And this will be our answers. So the second one is establish flow relationships. And we have our material flow from above points and units. I mean the components, and we have our variables. So it's E total is total E waste generated. C collect equals alpha times E total, and that is collected E waste. And R recycle equals beta times C collect is recycled E waste, where beta is the recycling efficiency. R refurbish equals times C collect equals refurbished e-waste, where it is the refurbishing efficiency, and R remanufacture equals it times C collect, and it is remanufactured e-waste, where it is the remanufacturing efficiencies. And we will simulate the scenarios using this code. So we have run scenarios varying alpha, beta, gamma, and delta to see their impact on total e-waste reduction, cost, and environmental impact. So we have our sample Python code here for a simulation, and we will run the code. And as you can see here, we import numpy as np, which is it is a library for Python, and we run it, and we it is straightforward that we have our solution or answer, and I will copy the answer here, and we will insert it right here. So we have our collection rate, recycling, refurbishing, remanufacturing, and we have the waste reduced, and we have these two, and it is um, repeated 3 times. So we have read the simulation, and we have verified the results, and we're going to adjust the parameters to ensure more accurate problems, but this time it is only just an example. And we have our conclusions, And so the conclusion is using the conscious thinking method or the E5 method to implement and evaluate a circular economy model for e-waste management ensures a systematic and comprehensive approach. It enhances understanding, improves decision making, and fosters sustainable practices in electronic waste management. The structured approach leads to more effective and efficient solutions, which ultimately contributing to a more sustainable environment. Okay, so that's it about circular economy. I hope you enjoy it. Assalamualaikum warahmatullahi wabarakatuh.